All right, everybody, welcome back. All right, so we are going to be working on section 4.2 at this point in time. Now, one of the things, it's raining like cats and dogs outside right now. It's really coming down. But besides the point, let's go back to statistics. All right, so section 4.2, we're still dealing with probability, but at this point in time, we want to deal with what is known as the addition rule in probability. And the addition rule revolves around working with compound events. Now, compound events, this is going to be when we're looking at more than one event occurring within a sample space. So one of the items that we want to look at is when these two events occur, how would we then calculate the probability of both of them occurring, right? So we want some notation that we need to work with. That notation is going to be probability of A or B occurring. In order to calculate it, we're going to have to find what is the probability of the individual event A occurring, what is the probability of event B occurring, and then finding what is the probability of both of those events occurring at the same time. In other words, P of A and B. So when we do this, we're going to have to make sure that we account for that probability of the two events occurring in case they overlap. Because if they overlap, meaning if they have a probability that both of them can occur at the same time, it's possible that we won't get an accurate probability. So before we get into the whole math behind it, we want to go through and we want to identify one more thing. And that one more thing that we want to identify is going to be here in red. And it says that these two events are going to be disjoint. In other words, two events are going to be mutually exclusive if they cannot occur at the same time. All right, that's going to be important for us to know. So when we want to look at this and when we're talking about these events, imagine a Venn diagram where this one here is going to be event A and this one here is going to be event B. If the two do not overlap like I drew them here, then we're going to say that the events are disjoint. However, if when we draw a Venn diagram, or if when we consider two different events, if we have some intersection here, then that means that the events do overlap, and that means that they can occur at the same time. All right, so in the next examples, we now want to determine, are these events disjoint? Meaning, can the events occur simultaneously at the same time? So, I want you to take a moment and try to see if you can identify part A, B, C, and D as well. All right, now I'm going to pause the video really quickly, and when I come back, I'm going to have this filled in, and then we're going to talk about it. So I would like you to do the same. Pause the video, and then try to see if you can identify if these events are disjoint or not. And I'm back. So looking at the first example, if A is the event that a coin lands on heads, and B is the event that a coin lands on tails, then these events cannot occur at the same time, right? Because a coin has to land either heads or tails by how we defined those events. So it's not possible for a coin to land heads and tails at the same time. Therefore, these two events are disjoint. Part B, event A is the numbers 1, 2, 3, 4. Event B is the numbers 2, 3, 5, 6, 7. Notice that they share two of the same outcomes. They share the number 2 together and they share the number 3 together. Therefore, if I were to say what is the probability of 2 occurring, since 2 occurs in either of these events, they are not disjoint. Part C, a person plays soccer or a person plays baseball. Now, we're going to identify these events. Can one person play soccer and can the same person play baseball? Yes, they sure can. If they're multi-athletes, by all means, they could play soccer in the morning, baseball in the afternoon, vice versa. Number D, or part D. Event A that we roll an even number on a 6-sided fair die. Event B, we roll an odd number on a 6-sided fair die. Now, looking at this, we should be able to classify this as disjoint because numbers are then classified into even numbers or odd numbers. And on a 6-sided fair die, only one of the sides can occur at one time, meaning we can only roll either an even number or an odd number, but not both at the same time. All right. Now, let's look at the next example. So in the next example, we have that they're giving us that the probability of event E occurring is 0.11, the probability of F occurring is 0.78, and the probability of G occurring is 0.56, and finally the probability of F and G occurring is 0.42. And they're also telling us that event E and event F are disjoint. So I want you to take a moment, pause the video, and see if you can use the formula that we were given up top in order to evaluate this. So I want to say use this formula right up here. All right, take some time to do that now. All right, and we're back. So on the first example, I went through and I wrote out the actual formula that we're using. Probability of F plus probability of G minus the probability of F and G. Now, substituting in the values that we were given within this example, we just have to apply some algebra through here. 0.78 plus 0.56 minus 0.42 should give us a probability of 0.92. Part B. Part B, we're going to go through the exact same process, listing out the formula, but one of the initial items that we see here is that the probability of E and F is actually 0. And that's because they're giving us that the two events are disjoint. If they're disjoint, then that means that the probability of them occurring together is not happening at all, which means all we need to do is add 0.11, that's the probability of E. We need to add 0.78, that's the probability of F. Therefore, we're going to get a probability of 0.89. Awesome. So now that we are understanding some basics of probabilities, what we want to do then is we want to extract it just a little bit more, and we want to work with this idea of finding a probability when we're looking at a deck of cards. So in this example, we're going to say, suppose that a single card is selected from a standard 52 card deck, such as below. So for us, we're looking at what is the probability that the card drawn is a king. So I want you to take a moment and look at this deck of cards. All right, if I ever give you a probability or a question like this on an exam, I would then provide you with the list of the deck of cards. Now, probability that the card is a king. So really quickly, what I want to do here is I'm going to go back to my notation, and I'm going to say that the probability here of a king, and I'm just going to write K. K is going to be that the event is a king. How many kings do we see here? Well, we should see 4 kings, and that's only 4 kings out of the 52 cards. So when we take 4 divided by 52, you put that into your calculator, you're going to get an answer, an estimated answer of 0.077. There we are. Now, what is the probability that the card drawn is a king or a queen? So the probability of a king or a queen. My apologies if you hear the noise in the background. That's my dog playing with her dog toy, so bear with that. All right, the probability of king or queen. Now, first of all, these two events are not mutually exclusive. They cannot occur at the same time. All right, or excuse me, they are mutually exclusive because they cannot occur at the same time. So the probability of choosing a king, well, that's going to be 4 out of 52. The probability of choosing a queen, well, how many queens are there? There's going to be, again, another 4 out of 52. Since they're mutually exclusive, we do not write the subtraction here. So this is only going to be 8 out of 52. Now 8 out of 52, you can put that into your calculator, and we should get something along the lines of an estimation of 0.154 as our answer. All right, now I want you to take some time, and I want you to actually fill in, I want you to actually complete part C, part D, and then once we get that, I'll go ahead and I'll explain what we're looking at there. And then I also want you to fill in the table down here. So I want you to fill in this table as well. All right, I'm going to put a pause on this video. I'm going to fill all this in, and when I come back, then we're going to start discussing this. All right, and we're back. So part C. For part C, we want to identify what is the probability that the card drawn is a jack or red. So if the probability of this is going to be that we're looking at a jack or a red card, then what I'm going to go through really quickly is I'm going to isolate that we have these 4 jacks, and then I'm also going to isolate here that we have these red cards. So these red cards are hearts or they are diamonds. That's half the deck. Now, because that's half the deck already, that's going to be 26 of them. So first, I want the probability of the card being a jack, and that's this probability being a jack. That's going to be 4 cards out of the 52. Then we want the probability of the card being red. That's going to be 26 out of 52. Now, we have to subtract out the overlap. And notice we do have some overlap of these two events. Pretend that these two are Venn diagrams. The overlap's happening in here. So how many cards are in that overlap? That's going to be here. Those are the 2 cards. So we have to subtract that overlap because, again, we've double counted it. Now, making some calculations here, we get 28 out of 52. That's the probability in fraction form. And then we also get the probability of 0.583 as our probability in decimal form. 538, sorry. I believe I said 583, but it's 538. Now, looking at part D. When we're looking at part D, we're then going to be talking about finding what is the probability that the card selected is an odd number or a heart. So the odd numbers, and we're just going to go by the strict definition of odd numbers, they must be 3, 5, 7, 9. So that in itself is just 16 cards, and that's this probability here. 16 out of 52 are only odd number cards. Now, what's the probability of getting a heart? So again, hearts, that's only this one suit. Out of those suits, there's 13 of them, so that's this probability. And then we also have a probability that we're going to subtract out, and that's a probability of the overlap. That's all these cards, which means there are 4 different cards that overlap, and that's what we subtract out. So the answer should be 25 out of 52, in other words, 0.481. Awesome. So now that we have this, this idea of whole probabilities, extending them into card values, or finding probabilities using card values, we now want to switch gears just a little bit and start using probabilities using tables. So in this example, we're going to say that a study of 1,000 recent deceased people is summarized in the following table. So the cause of death here could have been either cancer, heart disease, or other. And then we're also going to have that some of these people were smokers and some of these people were non-smokers. So we want to find, for part A, what's the probability that somebody died of cancer? So the probability that somebody died of cancer, again, that's the event that somebody died of cancer. That's going to be 200 out of the 1,000. Awesome. All right, now I'm going to put pause really quick. I'm going to fill everything else in, and then we'll come back and talk about this. All right, and we're back. So we want to find these probabilities. Now I want you to pay attention to the notation that I'm using here. All right, the notation that I'm using here is the notation of a complement. In order to find this probability, we're going to have to do it as 800 over 1,000. and I'll continue this video on another session.